All right, so this is a demonstration of the project that I worked on. The goal was to create a vending machine, a standalone machine, if you will, that presents a list of VMs that you could order. And what it takes in input is Ethereum, so crypto. So you would send this vending machine Ethereum crypto, Ethereum coins, and it will get you the machine, VM machine that you ordered. The way you select the machine is based on QR codes. So different machines would have different QR codes. So you would take your phone that has Ethereum wallet on it, scan the QR code, and send it the amount that it needs in order for the vending machine to take action. And then when it receives the funding, then it will create the machine and present the machine details or connectivity information to the screen. And then you would just capture that and then use it. I'd imagine for for a certain amount, you would it would be a lease policy, right? So for X amount of money, you would get N number of months or weeks or days. So that's the basic idea. I didn't get too far. So my focus initially was to figure out how to detect, deal with crypto, right? Just to take uh, money that was sent to the vending machine. So the way this works is you first have to run or have a node, Ethereum node, which is essentially an endpoint, a server. That's part of the Ethereum network. And you could either run one on your own, which I found out the hard way that it takes quite a bit of resource. So it needs around 300 megabytes right now. And of course, it will grow as time passes. Megabytes of storage. I think it recommends 16 gigabytes of RAM and a couple of CPUs. And it takes anywhere from half a day to a full day to download all of that data from the network, from the Ethereum network. And once it's synchronized, then you can query and do actions on the Ethereum network through your node. So rather than setting that up, and I tried, it took a while, so I gave up on it. It turns out there are free nodes that you can use. The kind of the caveat is that you're only allowed a certain amount of activities. I didn't figure out what that is, but so you obviously shouldn't use it for production. If you want to do something for production, you should run your own node. So first task was to get the node, get access to the node, and you just sign up to this inferia.org website, and then you get your own access to their node. Thereafter, it was just kind of learning how to use the API. They call it the Web3 library, and there's one for JavaScript, but I used the one for Python. So basically, connect to your node using through the Python library. Connect to the node, then you're issuing commands or creating wallets and whatnot. So the script, general kind of the high level overview is that it creates a wallet for us to use to receive funding or receive Ethereum coins. Then once it receives a certain amount, then it would go and try and create the VM. So anything else besides that? So the approach that I took is fairly naive one. So there are other options in the Ethereum space. You could use callbacks. So callbacks is a little more sophisticated. Basically, you're saying if anything changes to the wallet, um, just notify me rather than what I implemented, which was constantly polling the wallet for activity or change in funding. So that's what I did. The other approach that Ethereum provides is smart contracts. So smart contract is much more sophisticated, but basically you would create a contract that basically says, given the user submitting X number of or X amount of Ethereum, that once that agreed upon amount has been uploaded or sent to that contract, then the contract will make a mark on the make a note of it in the contract that says I this service owes that wallet or the sender rather the machine that was requested. Now, the contract itself won't create the machine. It is merely a kind of a legal document that's sitting in the network, which says, here's the amount I received, and here's the machine that you agreed. And it is basically two fields: the amount that was received, and it could be anything from a boolean or a string or an integer that says, here's what you owe in return. So it's something that the contract, you define what is in the contract in the simplest form, which basically kind of defines what was given and what should be produced or returned. So it's just a state document, right? And so what actually actuates the contract is an external service. So you would need another service or Python script that monitors that contract for actuation. So maybe there would be another flag that says, has this contract been fulfilled by the service provider? Like a Boolean or something. So it would be another variable. And if it sees that Boolean, then it would actually act on that contract. So as you can see, it's a lot more sophisticated than just monitoring a wallet to see if the balance changed. But it is quite interesting. The flexibility is really good in that you can put in any kind of data you want. Now, the constraint is that contracts, the larger the state document in terms of bytes, the more gas you'll need in order to act on it, or the more operations it needs, meaning compute, any kind of activity you need if in terms of calculations or transfer of funds. Those each have a certain amount of gas fee, which is essentially Ethereum. So it costs more the larger and more complex your contract is. All right, so that's kind of the overview. So let's run through the demo. Now, I didn't get to the VM creation part. I did spend maybe half a day on it, but then I gave up because it's not trivial to do. So the other approach, rather than using Python to try and just create a VM, would be to use VRA or some other automation service. Okay. So let's go to this demo script, test one. So let me just fire this up. So what happens in this script is, as you can see, it's really small. So the first thing it does is it connects to the test network. So that's the other thing. So you might have wondered like, oh, are you testing with real funding? No, I'm using Ethereum's test network. So the nice thing about the test network is it's just like the real network, except it's kind of like a parallel universe almost, where in this network, there are these services called faucets, which you can just tap for and get free Ethereum. I think I have, yeah, this one. So you could just, so in this test network, this service, for example, if you punch in your address and, click this button, you'll get 1 Ethereum. And so I use this service to get 1 Ethereum in my wallet. So the other thing I want to show you right now is the wallet itself. So I, as a customer, I can have many different kinds of wallet. The one that I'm using right now is called MetaMask. It's a browser extension based wallet. And as you can see, this extension is just you can use it as, and it's a little button in the Firefox in this case. So this is the MetaMask icon. Don't confuse that with Firefox, they're different. So one thing I want to show you right away is that the test network you can see here. So I'm on this Ropsten test network. You could easily switch over to the real one. As you can see, I have 0 Ethereum in that one. And there are all these other networks as well. So as you can see, I had 1 Ethereum and I started sending it during this development. All right, so that is that. And so my script is running right now. And so when it's running, it first connects to that test network. And in order to get access to this network, I needed to register against this Inferior service and Inferior IO. And once you sign up, they give you this access URL, endpoint that you can use. So I just connect to that, and then first thing I do is create an account. So you wouldn't do this in a real production vending machine. You would do this once to create the wallet, or maybe even just manually feed a wallet here. But in this case, so every time the script runs, it creates a new wallet, which can be annoying. So it creates the wallet and then it starts monitoring that wallet. So you can see it gets the balance and then that checks for changes to that balance forever, sleeping 1 second in between checks. All right, so that's the demo script. It's running right now. The wallet address is that. Let me copy that over. And I'm just going to send it some funding from my MetaMask wallet. Let's give it 0.2 Ethereum. You can increase the gas fee to kind of speed up the transaction, but you don't have to. Confirm. Okay. In this network, it's slower than the real Ethereum network, mainly because I guess there aren't as many miners. But in the real network, it would take about 4 seconds or less for the transaction to come through. But in this case, I've seen as slow as 20 seconds. So basically, it's looping through this right now and then checking for the balance to change. So we should get a balance of 0.3 Ethereum showing up at some point. Oh, there it is. So it just showed up, or 0.2 rather. So notice the balance, the amount is much larger than what we had sent, because one Ethereum is actually, I think, like really large unit of what they call Wei units. And so 0.2 Ethereum is this many number of Wei units. So it's just a different unit base. So they count, so each Ethereum or Wei unit is based on uint, unsigned integer. Right. I think that's about it for the demo. Oh, I did want to mention, I think I already did, was the VM creation. So I try to use Python to create VM, but it wasn't working for me. Initially I thought it was going to be fairly simple from some sample code, but it refers to these other samples and it became a big old mess and it wasn't running. So not so easy to run vCenter VM creation from Python. But anyway, so that wasn't done, but at least the Ethereum part was working. I wish I had some time to get the smart contract working. That would have been cooler. And as for the callback, I believe Python doesn't support it. So whereas Node.js does, so that would have been also an interesting way to do it rather than polling. Okay, I think that's it for me. Thank you. Let me stop recording.